Okay, so our next chapter to deal with deals with types of reactions, which is the seventh unit. So types of reactions, the topic there's so many different kinds of reactions that exist out there. So in this course, we're filtering it down to the ones that we feel are the most important, which are what are called combination or synthesis reactions, decomposition, single replacement, double replacement, and combustion. So let's talk about them one at a time and understand how they function, how they work. So the first type is a combination reaction. Excuse me. And so what happens in a combination reaction is what it sounds like. It's things combine. And so the way to identify if a reaction is a combination reaction or not is to look at the overall reaction and see what you have to start with and what you end up with at the end. And a combination reaction, by definition, is a reaction in which you have two or more substances that come together to make only one product, one kind of product. So look at these examples. Sulfur plus oxygen makes SO2. Sulfur and oxygen can make SO3. So you see how there's two kinds of substances here that are turning into one individual kind of product. And then the last example here of iron and sulfur making Fe2S3. So if you could pause this, go to this YouTube video and see some examples of some combination reactions. The next type of reaction is a decomposition reaction, which is the absolute opposite of combination. So combination is coming together, decomposition is falling apart. So you can tell easily that a reaction is a decomposition reaction because you have one reactant, just one reactant that falls apart into 2, 3, 4, whatever number of products. Okay, so you have one reactant for decomposition. For combination, it's one product. For decomposition, it's one reactant. Okay, so these reactions, they kind of get tricky if you do them for a while. And so we're never going to ask you to predict any of the products, just to be able to identify them. So here are some examples. So H2O2, good old-fashioned water, falling apart into H2 and O2. So one reactant falling apart. KClO3 falling apart, decomposing into KCl and O2. Mercury 2 oxide, HGO, falling apart into liquid mercury and oxygen, again, falling apart. So here are some examples. I'd like you to, again, pause, go to this YouTube clip so that you can see how this works.